In this video, I'm going to give you some tips and tricks about our mini project that is regarding exponential decay. So first, we have an example. A car's value depreciates 20% each year. The car was originally purchased for $15,000. So what it means when a value depreciates is it decreases or it gets smaller and smaller as each year goes on. The value V of t is modeled by the equation V of t equals 15,000 times 0.8 to the t power. Now this is another example of exponential decay. In class we had talked about something like P of t equals P naught e to the negative kt. So let me just talk to you about the differences between these two because they're both examples of exponential decay. So on the right, this is continuous decay. That means that whatever we're talking about, so let's say the example that we saw is some radioactive element. Each second that goes by, it's decaying. So the value or the amount that's there is different from 1 second to the next, even smaller than that. But let's just go with that for now. For our equation on the left, the value is changing each year. So within a year, the value of the car stays the same, and the next year is when the value changes. And then it stays the same within that year. And then the next year, the value changes. It's changing exponentially, which means that it's changing by the same percentage each year rather than the same amount. But I just wanted to take a minute to explain why you see an exponential decay equation in this mini project that is different than the continuous exponential decay that we saw in the notes. Oops. Okay. So example continued. So we have our car's value depreciates by 20% each year. The car was originally purchased for $15,000. So use the function, so the one that I just had on the previous slide, times 0.8 t. Okay, so we're supposed to fill in this table. So when t equals 0 actually is the original value of the car. When t equals 1, what we would do is we would take our equation and plug in 1 for t, and if we evaluate this, we get 12,000. Okay, now the difference from the previous year, so right now this is year 1, so the value of the car that it was purchased stayed the same. A year passed, the value changed. So the difference from the previous year is 15,000 minus 12,000, which would be 3,000. And we do the same thing for t equals 2. So we have 15,000, 0.8 to the second power. If we evaluate this, this is 9,600. Okay, and the difference in value from the previous year, the car was valued at 12,000 minus 9,600, which is what we just found. This gives us 2,400. Okay, so notice in the mini project, you're going to continue this table farther, I think up to 5 years. But look at the difference here. It lost more in terms of dollar amount from year 0 to year 1 than year 1 to year 2. Okay. The other thing that you're asked to do is you're asked to determine when the car will lose half its original value. So again, we have our equation. Okay. Half its original value, so we're determining when, so we don't know t. Half its original value, so we would take 15,000 and divide by 2 to get 7,500. So this is V of t. So when it's saying half of its original value, it's giving us a value for V of t. So if we substitute that in, okay, and we have an exponential equation to solve. Just to help get you started, we get our base with our exponent on its own. So 7,500 divided by 15,000 is 1/2. This is 0.8 raised to the power of t. You would use logarithms in order to solve for t. Okay, and then round to wherever it says to round to in the mini project. Right? If you have any questions, let me know.